Hi. In this video, I am going to go through the poll for fall of 2024. Now, I have to warn you, this is going to be a long video. This was a long poll. I will also be kind of taking a lot of time trying to get through all of the basics here, really more treating this as a whole supplemental lesson. Please feel free to scrub through and find just the questions you're asking about, or you can watch the whole thing and just treat it as a supplementary lesson, especially if you are confused by concepts like data type conversion or extraction using some of our various tools like square brackets with a comma, $sign, and double square brackets. So let's get started. So this first question is trying to get you to think about how does data get combined. In R and in many other languages, we have to pay careful attention to how data is structured. The reason why is even though the programming language helps to allow us to avoid thinking about certain concepts regarding memory, we do still have to think about it a little bit. And so one of the things that we need to know is that in R, a vector, so a one-dimensional object, has a single type. So there are complex types like lists, where each position within that list type vector can contain a separate type of data inside. But overall, it's a list. That's our most complex. R doesn't like to put things into lists unless it has to. It's very memory inefficient. On the other end of the scale, we have things like a logical vector, something very simple. It has three possible values. It has true, false, and missing. And so in between there, we have different types of data, some of which are easier to use, some of which are a little bit harder to understand. I didn't really put any of the harder to understand ones in here, except for maybe complex. But they're generally here listed in order. We have our simplest, so raw binary, so 1 or 0. We have logical, true, false, which can be represented as 1 or 0, and missing. We have integer, so 1, -1, 2, -2, out to a pretty large number, not actually infinity. There is a confined number of digits an integer can have in R because of how it stores it in memory. So again, we don't normally have to deal with it unless you're working with absurdly large numbers, but there is theoretical limits here. Double, similar kind of limits apply, but they are much larger. So like 300 orders of magnitude. So very, very large and very, very small numbers are possible with what we call double precision floating point values, or just easily numeric. Complex is similar, but it adds the ability of imaginary numbers to that. There may be some other complexities that it allows, but I don't really interact with complex values very often, and so I'm not super familiar with that type. Character is one that I am quite familiar with. A character is going to be just any string of text, which can include character character symbols. It can contain symbols, so like greater than symbol, an exclamation point. And it can contain numerals, as well as many other things that you may not be thinking of, so like umlauts, overuse, and just various different symbols that you don't really think of. There is a finite list, but the nice thing is it allows you to store very large pieces of text. I don't know the upper limit. There probably is an upper limit, but I've never reached it, and I've stored some very large character values before, like a whole chromosome, so millions of characters. Millions of we do call them characters, so the characters inside of the character vector. It is confusing because we keep reusing the same term. But we can store quite a lot of information in each one, but the important thing is that it stores different symbols. That's certainly not possible in a double precision point value, and that's the general idea. A list being a type of data that is stored as a vector. So it's stored in a linear format. So it is a series of containers. But inside of each container, you can have multiple types of data. You can even have multidimensional data. It's more that they are contained. That's the important thing. So it is a type, but it can contain data inside of that type that is of different types. So a nesting of sorts. Okay, so applying it back to this question, we have what is the type of data? Well, it turns out you can't represent the letter A as a number. And so R is programmed if you are trying to combine these more simple types of data. So this is going to end up as a numeric type data or double with a character data. It is going to have to convert each of these numeric data types into a character data type. And so you're going to get character. If you print this off, it's going to print off quotation marks around each character. And that is how you can also know. That's actually because of the class system, because a simple character vector also has the class character. It causes it to print like a character does, which is with quotation marks around it. Next up. The next step question is asking what is the function that must complete first? So there's a lot of other information in here. There's information on like what actually ends up happening. So I show you like in the end, it does convert to a logical value, although it turns out that that first object, it doesn't do it very well because they all end up missing. Whereas object 3 is fully successful of converting each of these values into false and true, with basically 0 becoming false and any other number becoming true. Here, none of them became true, but that's the next question. So let's come back to that. The actual question here is asking what must happen first. And so you can identify the different functions here. This assignment is technically a function. This as.logical is obviously a function because it has its parenthetical. The C is a function, again, has its parenthetical. This is just a single value. I don't believe anybody would consider any of that a function, so that's just a value. It is a length 1 numeric vector, as is. Length 1 numeric vector, length 1 numeric vector, length 1 numeric vector, length 1 character vector. They then have to be combined first, because what are you going to call as.logical on if the C hasn't completed? In turn, what are you going to assign to the object 2 if you haven't run as.logical? And so if you just backtrack and you kind of think of this as a chain of cause and effect, it means that C must have happened first. And so if you look through your options, I had those 3 different functions, but the only one I list as an option is C. And ooh, I was cruel and I made other choice. I should have made other choice. I didn't want you to be confused by that, but I'll have to go check to see how I submitted that one later. But C had to complete first. Okay, so the next question is asking, cool. You've thought about this question. You've thought about the order of operations. This is actually an example of the kind of code that I run whenever I am trying to determine the answer to things. Like if I am doing an experiment looking at survey data and I am trying to see like, all right, well, what happens in this situation where I have a bunch of students submitting numbers or participants submitting numbers, but then one cheeky little person puts some text in there that doesn't convert very well. Will that still end up producing a logical value? And so I might simulate that. So a 0, a 0.5, a 1, a 1.5, and the letter A. Well, it turns out because that letter A is in there, it can't all be stored in a single object, and that causes it to be coerced into a character vector. That's the problem, is that a character vector being converted straight to a logical is different from a numeric vector being converted into a logical. It's a different set of protocols, and those protocols do not allow you to go from the character 0 directly to a true or false. It doesn't allow you to go from the character A to true or false, certainly. Whereas the opposite is not true here. The numeric vector does have instructions on how to go from a numeric vector to a logical. And the way you would know this, and this is, again, more of an example of how I would write this on a test or how I would be experimenting with in real life, I've given you all the information you need down here. We can see that outcome. If we understand that C has to combine things, it has to coerce them into a single type, and then we realize that that results in a difference in behavior on the as.logical function. The only conclusion we can draw, or at least the only one I'm thinking of and have thought of, is that it's due to these becoming a character vector. And that is absolutely what I'm trying to draw your attention to. It is also the truth. That's why it happens. I just don't know if you thought of any other ideas. So anyways, coming through these answer choices, it is the character 0 cannot be coerced into a logical value. The number 0 was coerced into a logical value. So 0 became false successfully. Character 0, which is what this became, did not. And the same applies to the rest of this. Obviously, this one's not true. We can see this having happened right here. And that takes us to the end of the answer choices. Next question. It says, use the below output in conjunction with the prior example to extrapolate what the values of object 2 will be. And so again, giving you an example of how I do this kind of stuff. And I do write these little snippets of code inside of my script files as I'm experimenting. This is how I learn and learned this skill, is through a lot of experimentation. And so I'm really just trying to encourage y'all to try these things. Okay, so it says use the below output in conjunction. You should pick a column value for each row. And so I'm asking what's going to happen to each of these. So we can see the first thing that's going to have to happen is the C. We witnessed in that previous example, C is going to happen first. It is going to cause things to become coerced. We have an example here of how as.numeric on a character vector will work. The number will successfully be coerced into a number. The letter will not, which means this will successfully, once the as.numeric runs on the character 0 and the character 0.5, and blah, 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 through the character A, this will get converted back to a number. This will get converted back to a number. This one will, but this one will become an A. And the direct example is in the same question. At that point, I then start running as.logical. And if I refer back to the previous example, I can go find that 0 becomes false in an as.logical, the number 0, because this kind of went back and forth, right? So at this point, this is the number 0. That's the number 0.5. Anything that's not 0, any number that's not 0 will become true. And so this will become true, true, true. And this was in A at this point after the as.numeric. And so when as.logical runs on a numeric value of missing, it's in A. And so the answer becomes false, true, 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 and that remains missing. Quite tricky, but realistic. It's the kind of tricky we do have to pay attention to. It's a little bit of an extreme example. And I'm kind of I'm doing things all in one step here in a way that's probably not the best way to code. But the idea is more to just demonstrate and teach concepts, right? In real life, for the record, you should probably separate that into multiple sets, maybe even like multiple columns, so that way you can check later just to make sure everything did work as you expect. That's usually how I would do it. Memory is fairly cheap these days. Okay, so this next question, I'm basically asking you to, here's the code, I'm printing the object, I'm calling summary on the object, I'm calling structure on the object. I'm then showing you those results, and I'm asking you to draw a conclusion. What type of data is object 6? And I've actually redacted that information from the structure because it does print off when you print when you print the output of structure, what that type of data is. And really, there's two things you just have to know if you've just gone through and you've studied your different types of different classes of objects. In R, you should know a few different things. Well, first of all, we've discussed at least two different types of two different classes. Sorry, it is very challenging vocabulary. Two different classes of two-dimensional data. We've discussed matrices, which look like this, at least vaguely like this. There are some discrepancies that I wouldn't have asked you to memorize from just this appearance. And a data frame, which, hint, this is a data frame. This is what a data frame looks like when it gets printed. Okay, so it's two-dimensional. So you already know it's not a vector. It's you can eliminate all of these vector choices, which includes list. A list class object is just a vector of containers, which subsequently may have multiple dimensions. But so we can eliminate everything but data frame and matrix. Cool. So then we look at this bottom section and we just have to think, all right, well, could this be a matrix or could this be a data frame? And if you can't interpret summary, so summary is showing us that column 1 is a logical object. Column 2 is some sort of number, probably. It is. Column 3, some sort of number, probably. This one, yeah, we'll come back to. Column 4, I probably wouldn't have recognized this, to be honest. I would have guessed that it's a factor, which is in fact what it is. I try to avoid factors. I find them confusing because they print off like characters, but they're actually stored in data as integers. It's a confusing type of data. And then finally, the last one is a character. We can see that its class is character, its type, so mode is another term for type. Similar, it uses a different set of definitions for like what does it mean to be a character, but largely it's going to give you the same information. It's type with a couple of discrepancies. So last one, this structure though, very clearly shows us that we have a logical data, we have integer data, we have numeric data, we have factor data, and we have character data. The only class of object that this could represent that can hold multiple types of data is the data frame. That's its whole job, but because it has that list structure, so it is stored in memory as a list, each container, so this is container 1, container 2, container 3, each container can contain a different type of data. Matrix doesn't have that ability, and so this clearly cannot be a matrix. So those are really the two properties. You had to know the property that it is two-dimensional. Cool, so that's matrix or data frame, and then you had to know to differentiate between the two. A data frame can store multiple types of data. Thus, the answer is data frame. So it is a matrix can only store one type of data. Data frame can have more than one type of data because each column is a container within a list type object. That object being the data frame. Oh, that's so small. This is a high resolution video. Okay. Continuing forward. Here is an object. Ooh, which of the following, this is going to get weird because this is a very long video. Here is an object. Which of the below codes could replace the redacted code, so the hidden code down here? So if I look through here, I can see that these values come from this. Another thing that I'm noticing is not just that it is this column, it is in fact the contents of this column. The difference being this column is part of a data frame. It is actually a container within a list type object. It's the second position within that list type object. It has the class data frame, but this right here does not. This is printing as a vector, and that's because it's the contents, which means that everything I pick down here will need to return the contents of that column. So the ones that do that are this one, and this one. This one, because that's what $sign does, it returns the contents of that container. Double square bracket, same thing. That's its whole thing, is it returns the contents of that container. The added ability of double square brackets as opposed to $sign, which I prefer $sign, is that the square brackets allows you to pull out by number, so by position within that list type data. Now, some students are going to pick this one, and if you run it, it does run and it pulls out the similar values, but the type of data it pulls out is actually the entire container. So if we imagine like a list is a series of containers, it's pulling out that whole dang jar, as opposed to opening up the jar, reaching inside, and pulling out those values, which is what we're actually doing. A very subtle difference, but one that seriously affects downstream analyses. I will tell you, that took me an embarrassing, I don't even want to say the number. It took me an embarrassingly long time to finally I had to go look up the difference between those. And it was just, I was struggling in a project I was working on. I was like, I can't figure out what's going on. And once I realized it, and someone found it online or experimented or something, it was much simpler. But yeah, embarrassingly long time to figure that out. So this is the container itself, the second position. And if you think about it, it's because it's using the multi-dimensional extraction tool, so the single square brackets, with a single argument, which means it's going to function in a one-dimensional kind of capacity. Well, that means it's going to access that underlying list vector structure. And so it's going to pull out that second container, and it's the whole dang container, not the contents. Cool, I spent way too much time on that, but that's the idea. This would just pull out the first row, second row, cross everything. Actually return a data frame, because if I'm pulling out the second value in each of these containers, it's not safe to simplify that into a vector, because they're actually different sections of memory. They're stored in different ways. And so R doesn't try to simplify those together, because it could potentially destroy the data. And so anytime you end up extracting multiple columns from a data frame, it will remain a data frame, unless you do downstream stuff to it. So you can always change that later on, but this right here will return a data frame of the second row only. One row, multi-column data frame. This right here would extract from sepal width, but then it would be subsetting that. So that's used in the next question. So that's what's happening here. How do we get these values? Well, this would get us the whole column, so that'd be pretty close, but it wouldn't. It would contain 3.5, 3.6, and 3.9. Similar, but this would return a data frame. Same as that first option, Second row as a data frame, not at all what we're asking for. Extract that column, then from that resulting vector, ooh, that's the key. Because it's a vector, I need to choose this one, as opposed to, say, this one, which I think is probably what most people who miss this question will pick, because it did correspond originally to rows 2 through 4, so I can see why you would pick that. But once you've extracted from sepal width, it's no longer a data frame. This is why I spend time, because of this dynamic, that as I do data manipulation, I manipulate the data, which changes its structure, changes its type, changes how I interact with it. And so this one works. This one returns an error message saying there's not a right number of dimensions to be using this tool, which would require 2 dimensions because of this comma here. Same problem with this one, although this one makes less sense. This would be trying to take this vector and extract the second, third, and fourth column. Clearly, this vector won't have columns, and that wouldn't have been a good choice even if it was a data frame still. So not the right answer. This one, that's not how this bracket tool works. I know it looks similar to this square bracket, but this tool works similar to $sign. And at this point, sepal width is no longer a list. So even if that could work and it could get the contents of the second, third, and fourth container all at once, It wouldn't because it's not a list anyways. So first of all, would it work? I can only give a single value to double square brackets, just as I can only give a single value to $sign. So it doesn't work at all. But even if it did, it still wouldn't work because it works on list type data. And $sign sepal width from IR head, that's not a list anymore. It changed. This one totally works. We are fully leaning into the capabilities of the double square brackets, selecting a subset based on the first dimension and selecting a subset based on the second dimension, giving us rows 2, 3, and 4 across column 2. And so that all happens simultaneously, which means we don't need to be worried about the dynamics in this. This is a single extraction event. I like that question. Hopefully, if you can understand like everything I just said, you are doing fantastic. Truly, that's I'm just tooting my own horn here. This is just me being proud of myself. It's a good question. Okay. So just a few things, trying to get you to start thinking ahead. We are transitioning into like using the extractions. So obviously I'm not just like, oh, I need to extract the second column because I was told to do so. I extract data because I need that data, or I need to use it to control something else, or I'm doing an analysis. So let's start putting it into context. Well, to get there, I wanted you to think about how we can start doing analyses to control our extractions. Cool. So easy enough. This is less than or greater than. So this will, or less than or greater than? There is a symbol for that. It's not equals to. So exclamation point equal sign. That's not what this is. This is less than or equal to, which you would totally think if you just read these symbols. Don't know why I said that. All right, let's keep on. So this is going to be 1, 2, 3, 4, 5. So it is a length 5 integer vector, turns out. You really have to very rarely worry about integer versus numeric for the record. So if I compare 1, 2, 3, and 4, and 5 to 3, I'm going to get true, 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 false, false. Really the only tricky part, if you think that's tricky, is whether or not this one should be true or this one will be false. Well, because that's less than or equal to, it's this one. Let's make it a little bit more challenging. What all would be returned? So here I have some data. Here I use that same data inside of a comparison. You will see me do this a lot. I will be extracting from an object using an extraction tool that refers to that same object. And the reason I do that is because I often want to use the data inside of an object to control what data I want from that object, which is precisely what I'm doing here. So here I am trying, I'll just tell you, I'm trying to extract values less than 3 from the object to the left. So to do that, I take the object to the left as like the starting point. I start my extraction. I pull that same data and I compare it to the number 3. This, oh, I can highlight this. Nice. Okay, I didn't. I'll get it. This all together results in a logical vector. At some instantaneous point in the calculation, this has to end up resolving. That is actually 2 functions that have had to occur. That colon had to happen before this less than symbol, and then this less than symbol has to happen before the extraction symbols can work. And that's just kind of logic, but it's also how the order of operations in R works. For the record, because this is the poll stuff and it's also intended to help you be able to like wrap your head around test-like questions, if you're ever unclear, please just ask me for help for order of operations. Unless like the point of the question is order of operations, I'll help you out. Okay. So 1, 2, 3, 4, 5, as we just demonstrated, that should return true, true, false, 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 because this is not less than or equal to. So if I am then extracting from 1, 2, 3, 4, 5 with true, true, false, 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 I had to close my eyes for that, then I will get 1 and 2, and then the other ones will not be returned. None of those trues or falses get returned. Those were inside the square brackets. They were used as an argument, as like a parameter or option or whatever you want to call it to control the extraction. None of those trues and falses are returned. It's just use to do this extraction of the data outside. Next up, we have the letters function, which here, I got mean, and I was a little bit nice. I gave you parentheses just to make sure you weren't concerned about order of operations. It turns out the parentheses here not needed. These parentheses definitely needed. These parentheses not actually doing anything, just for the record. But here I am doing 5 through 1, so that means it's going to be a vector of E, D, C, B, and A in reverse order. And then I'm extracting the first and third position from that, so E, D, C. Not very challenging, but a little bit tricky. This next one, very strange way to generate logic. Acceptable. So like on your homework, there's a question and I ask you to generate some logic. If you just give me a combined function to provide that logic, you're welcome to. It's a very small C. Please don't give me the one where it would be 100 or 250,000 trues and falses. Wow, please don't do that. But there is a question where I ask you to only do like a small number of trues and falses. That's absolutely fine. But this is an example of how I can use a logical vector to extract. You know what also was that? This and this are very, very similar. The only difference is which values are true. So here I have selected that the third and the fifth position will be true. These are the same length. That is an essential part of the using logic to extract. That's why usually I'm using logic to extract that's based on the original objects. It needs to be the same length as what I'm extracting from. It has the capability of extracting when they're not the same length, but it does some really weird and hard to wrap your head around recycling of the shorter vector or the shorter dimension. When that happens, it does weird things, and I really strongly encourage you to pay careful attention to that. If you're using logic, it should be the same length as the dimension. Otherwise, weird stuff happens. All right. 3 and 5 are the corresponding positions to true and true here, and that's what gets returned. Right, I believe we're getting near the end. This asks which value or values does the following return? And so here I have IR head again, so just these 6 values. Here I am extracting the sepal width. So this is going to return a vector of the values inside of here. So it'll just be 3.5, 3.0, 3.2, and so on inside of a vector. Because it's inside of a vector, this needs to be a one-dimensional extraction, and it currently is. I can tell that because there's no commas on either side of this argument. Sometimes students do get confused because there's commas inside of a single argument. Well, if there's like parentheses around a C or something that's combining them first, then that comma doesn't go here. But that's not happening here. Don't know why I mentioned it. That may have confused you more. I'm sorry. Rewind, re-listen if that was confusing to you. But there is no comma that the square brackets see in here. Instead, they see what has resulted from a logical vector. So let's determine how that logical vector is created. Well, before that logical vector can be created, this $sign had to happen because otherwise, what are you comparing to the value 3? So this became the contents of petal width. So that became 0.2, a vector of all these values. It then compared that vector of values to 0.3, and that produced a logical vector. So everything I'm currently wiggling my cursor around became a logical vector of, let's see, false, 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 true. So if I use false, 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 I don't know how many, and end in true here, the last value, the one that is true, is the one that's going to get extracted. And since this corresponded to this, the value would be 3.9 because it is this value corresponding to this value? Hopefully that one makes sense. Again, that's a pretty good question of testing your understanding of this topic. It's putting a lot of things together. This is really what most of your homework is next week. So if you're good on this, just get started on the homework. You may want to skip that first question. Sorry. But the rest of the questions are very much related to that concept. Why have I provided the without a comma extraction only a single argument and not two? First of all, I am trying to trick you into realizing that this is a single argument, even though it looks like a bunch of stuff. It is a single argument because the square brackets only ever see the outcome of all this code inside of here as a single object. That's why it is a single argument and not two. I know, I'm just mushing together lots of learning. In other words, why use square brackets and not square brackets with a comma? So the answer is because the data being extracted from is a vector after the $ has done its job. Boom. Only one typo? Yeah. It's gotta be a record for me. And the winner this week is Yelling Person Throwing His Chair. Perhaps unsurprisingly. I do like that one. Although this one's really cute too. Anyways, I hope y'all learned something from that. Please give me feedback. I don't read the comments here because I've used the internet before and I know not to read comments. Anyways, y'all have a good day. Bye.